So today is October 23rd. And I just forgot to record the class lesson day. It was pretty quick, so this should only be maybe 15 minutes or so, maybe a little bit long. I might do it a little bit longer since it's a recording. We have a quiz coming up on Friday. This is the one I'm taking straight from the IXLs. I just sent a message out to everybody with the IXL codes. They're up in the room. I'll find them and I'll put them in this video also. Actually, let me try to remember them since I just did it. So I think these are the codes, if I remember correctly. So 5 codes: JUU, N5P, Q6E, RSV. Oh, and then I can't remember the other one. Hold on. I can find it real quick. Probably. Oh, maybe not. All right, I'll come back and try to find that. Hopefully that'll remind me. All right, so the first thing we did was this bell work. Let me get this stuff out of the way because we're going to need some of this. So we had to reflect a point. So the point's already on the graph. And we're doing it over x equals 1, and then we're going to do it a different one over y equals 1. So we've already done, just as a super fast review, we did a reflection over the y-axis. We did a reflection over the x-axis. I'm hoping that those are easy. I'm not spending a ton of time on them. Just remember ooh, that didn't work. The x-axis and the y-axis are labeled. Like that's the y-axis, that's the x. I would imagine they're always going to be labeled on anything you get for, the midterm. If apparently we may not have a midterm now, but if we have it or if we have the EOC, you shouldn't have to guess which axis is the x-axis and which is the y. So if I was reflecting it over the x-axis, which again, I'm not doing this, I'm just showing you examples. This is the x-axis, that would be my line of reflection. If I was reflecting it over the y-axis, that would be the y-axis, and I would reflect it over that. So with that in mind, it sort of makes sense if you don't really think about it, like you should think through it. If it says reflect over x equals 1, you might think, okay, well, if the x-axis is horizontal, if it's flat, x equals -1 is going to be flat. That is not correct. We said your intuition is not going to be correct if that's what you think. X equals 1 means every place on the line. That's x is -1 right there. Every place on our line, x has to continue to be -1. So if I graph a line, the only way to have x stay at -1 is to make it like that. That's graphing x is -1. So if x equals a number, if you just need to memorize it, that means it's going to be a straight up and down line, a vertical line, if x equals a number. And then you just find the number on the x-axis. So in this case, we're using -1. So then I just graph through -1 straight up and down. All right, now once you have the line of reflection, we said that's the most important part. Now all I do is I count toward that. So I say, all right, well, that's 1 hop, 2 hops. Oh, and don't stop at the y-axis because that's bold. Sometimes kids stop at it. And then I keep going 1 and 2. That's where my point goes. A lot of times they're going to want the coordinate, so make sure you know how to write a coordinate. The x value is first, that's -3. Then the y value is second, that's 2. There is a rule for this. I'm not even going to teach the rule. If for some reason you get a question about a rule, you can just try to figure it out based on what we know about the other reflections. But it's a little complex, and I'm trying to keep things as simple as possible, hoping that they don't get too complex on the EOC. All right, so now we'll do this second one. So if x equals a number is a vertical line, hopefully if you really just remember one of them, it should be kind of simple to make the connection that, okay, if x equals a number is vertical, y equals a number is going to be horizontal. So that's flat, left and right. So again, that's vertical and that's horizontal. I went through a big thing in class about how this is really in slope intercept form, y equals mx plus b form. M is the slope, b is the y-intercept. So the way that would really be written, I'm going to write it down below. Y equals, actually, I didn't do that for this one. I'm sorry. I mean, it is. It's really 0x because there's no x in there at all. So we have 0x's. And then plus 1 is really what that would be. 0 would be the slope. That's why it's flat. A slope of 0 means flat. This would be the y-intercept. So that's why we put a line through the 1. And again, it has to be horizontal. Y has to be 1 everywhere on that. So anywhere I'm at on that red line, the y value is 1. So that's how you graph y equals 1. Now that I've graphed it, again, I just do the same thing. 1, 2, 3, 1, 2, 3. So that's my point. And just make sure you can label it. That is 3, comma 4 for our point. 3, comma 4. All right. So the next piece is going to maybe get a little more difficult. It's still a reflection. We are going to reflect, though, over y equals x, which is the same thing as x equals y. We can flip the sides. If both sides are equal to each other, we can flip the sides. So these will have the same line of reflection. It'll look the same. All we're really doing is we're graphing those equations. So if you remember your algebra, which this is really an algebra skill that we're about to do, it's not really a geometry skill. The reflection part is the only geometry skill. This could be written as well. This is actually where I did it in class. Y equals x is really mx plus b form because the y is all by itself. Anytime y is all by itself, that's slope intercept form. So again, m is the slope. If you don't remember, the number with the x. It doesn't have to be the first number. It could be the second number if that's the number with x. So I'll give you an example in a minute. Actually, I'll do it right now. Let's get rid of this stuff. So if I have an equation, so again, I'm just making this up. It has nothing to do with the problems, just to show you that the slope doesn't have to be the first number. So if I have an equation y equals 2x plus 1, and I change it to this, y equals 1 plus 2x, 2 is the slope. It's with the x. So it doesn't have to be the first number. So make sure you understand or remember what's important is what is the number being multiplied times the x? Well, that's 2. That's your slope then. The b, which is the y-intercept, is the number all by itself, no matter where it is. That's the y-intercept. So the y-intercept, we said, that's where the line that we graph is going to hit the y-axis. So if I have a 1 that's all by itself, and that's the y-intercept, the line that I graph would have to go through 1 right there on the y-axis. I don't know yet which direction it's going to go from there. Maybe it goes up and to the right, up and to the left. I don't know. But that point right there is going to be on the line. It's going to hit the y-axis right there. So that's kind of why we use slope intercept form. We're going to do that in a second. So if we say that this right here is really y equals mx plus b format, we're just missing some stuff. We're missing the fact that there's really a 1 right there. So in class, well, hopefully everybody understood this. The 1 in front of an x does not mean x equals 1. Not even close. The 1 in front of the x is being multiplied times x. If we knew x was 1, we wouldn't need x. We use variables when we have an unknown number. So the 1 in front of the x is a totally separate thing from the x. The x is unknown. The reason we don't normally write 1 is because 1 times x is just equal to x. So there's no need to put the 1 there. We don't need to put 1 times something. It's just the same number. The b value, or the y-intercept, is 0. If there's nothing there, the number for nothing is 0. So that would be the y equals mx plus b format. So that means that number right there is the y-intercept. That's where it's going to hit the y-axis. So the line that we're going to graph is going to go through there, right through the origin where y is 0. The slope is 1. That's the number in front of the x. So the way that we graphed, if you happen to remember this, is we wrote the slope as a fraction. We wrote rise over run. And we said, okay, then I'm going to be going up 1. Well, I like going right 1. I'm going to go right 1 and then up 1. Right 1 and then up 1. And every time I go right 1 and up 1, I'm going to be putting a point. I could reverse those just to make the line even straighter and go the other direction. And that would be what my line would look like. I'll go ahead and use the same color I used in class. Well, that's not a great job of putting it in the right spot, but that's fine. I'll move it. So that's where the line, or how the line of reflection would look if we were reflecting it over y equals x. So again, I'm going to kind of erase that. You can go back and watch it if you need to. So the original problem said reflect over y equals x. It would be the same thing as if it said reflect over x equals y. And it could say across, not just over. Again, that's the same thing as saying reflect over y equals x. I'm sorry, x equals y. Another way to graph this, well, first you could just memorize, that's what it looks like. But if you also just think about what and I'll have you do it, you can pause. Think about, what does that equation mean? Like, what's it telling us has to be true? Either of those two equations are the same. So pause it, think about it real quick. You should be back. If not, pause it now. But that's just telling us that when we have an ordered pair, and I'm talking about the ordered pairs that will be on this line right here, if we pick any point on that line, the x value has to equal the y value. They have to be the same. That's what these equations are both telling us, that the x and the y are the same. So sure enough, if you look at the different points, that point right there is 4, comma 4. That's 4, 4. I'm sorry, 3, 3. That's 2, 2, 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 2. So I'm hoping you get the point. That's all you're really graphing, is just all the points where the x and the y are the same. So if you do a few of those and just connect them with a straight line, that's another way to graph this line of reflection, whichever one you get. You would only get one of them. You wouldn't get both. I'm just showing you they have the same line. So once you, oh, I forgot to put a point on here for us to graph. All right, so if that's our point, here's where it gets a little tricky. I can't just go like straight right or straight down and then keep going. Like I can't say, okay, well, I'm going to hop 2 down and then hop 2 down. That is not where the reflection would go. This point down at the bottom that I'm just making right now, that's much closer to the line of reflection. Actually, it's not much closer. It's just not on the correct opposite side of the line of reflection. A reflection would be perpendicular. If I'm looking at the mirror, it looks like it's directly behind it. What I just did is going sideways. That's like I'm looking sideways at the mirror. I wouldn't be able to see my own reflection if I'm looking sideways at a mirror. So we can't do that type of grid line counting in this. We can still go perpendicular. This is a little tricky, but if you just think about, well, how far away is this blue line? Let me use my mouse first. Actually, I might still. This blue dot from this line, perpendicular, would be the opposite diagonal direction. That would make it 90 degrees. If I'm going diagonally this way, and then I change and go diagonally this way, that's perpendicular. So I could just count straight across diagonally and say, well, that's one diagonal square. I'm not using the grid lines, but I can just say that's one diagonal. Well, if I go one more diagonal this way, this would be the point right here. Shoot. There. I guess I have to do it. I was trying to draw, but it didn't work. So that's where the point would go, one diagonal across. Now, if the point is a lot farther away, like let's say it was way over here and I was reflecting across the line, that you got to be a little more careful and just make sure some kids, they don't want to draw on the graph, I guess, or something. So they wind up, their eyes like get off and they stop going straight. But just draw straight. That's one diagonal, two diagonals, three diagonals, four diagonals. Well, keep going. One diagonal, two diagonals, three diagonals, and then four diagonals. It would be right there. I don't care if you draw on the graph to help keep it straight, just as long as you put the point in the correct spot. Now, if you don't like that, or if you're worried, or if you just want another option, there's another way to do it. We can use the grid lines, but we can't just go left or right, and we can't just go up or down. We have to kind of do both. So if the original point is right here, I go right to the line of reflection, and then I also go down to the line of reflection. Now on the other side of the line of reflection, I just kind of make two lines that'll make a square. I just take this point and go straight right, this point and go straight down, and that you'll see that meets where we already put the point. So again, your point will be on the opposite corner of the square from where you started. I'm going to erase this one just so we kind of do it from scratch without all the other stuff. Let's get rid of that. So again, if the point were right here, I would say, I'm going to even erase this stuff too. I go straight to the right. Well, I go toward the line of reflection. In this case, that's right. Then I go toward the line of reflection in the other direction, which is down. Now I just continue to go from these two places I stop. I go straight to the right. I go straight down until those lines meet. And if you'll notice, you'll always form a square when you do this. And the point will be on the opposite corner of the square from where you started, which is the same place we had put it before. So any of those works. I don't really care which one you do. It's all going to work. Just be careful. All right. So the next thing I did is I did a quick review. So this is coming from two IXLs, this last piece. So I did a quick review, first of all, of parallel lines and transversals. We said, all right, well, if we have two parallel lines, so they would have to tell us that, that means we're going to have a bunch of congruent angles. I'm not going to go through that whole process again, but basically the transversal, which is, oh, it's not going to let me do, oh, wait, actually, here, there we go. Well, maybe it didn't let me do that. Huh. All right, let me try this real quick. Oh, it did work. Okay. So the blue line is the transversal. It would normally have arrows on the end of all of them. I just didn't draw them on the end also. So that line is hitting every parallel line at the same slope, right? I mean, it's really hitting it at the same angle. That's really what you'd say it. So if it's hitting it at the same angle, it's going to create a bunch of the same angles. The lower left angles will always be the same. The upper left will always be the same. So this one will always. Did that not move backward? Well, let me try that again. That's weird. So this angle will always be the same. That's the lower left out of the four. As that. Every time you create a new intersection, the lower left will always be the same number. The upper right would always be the same number because again, you're creating angles that are, coming from slopes that stay the same throughout the whole picture, the whole image. So, and you can watch the other video if you want to get more detail on that. We said there's only two numbers that are ever going to appear because if this one number here is the same as that, And then this number here is the same as that, and that's because of vertical angles. Anytime two lines cross, opposite angles are congruent. That means we're just going to continually only get two numbers over and over again. So we said your only options for equations are either to set the two angles equal to each other or add the two angles together and set them equal to 180. So, and that kind of makes sense because if you think about it, we know this has to be 180. So those would be two angles you would set equal, or I'm sorry, you would add them together and set them equal to 180. We know vertical angles, like down here, would be equal. So those would be two angles you would set equal to each other and then solve for x. And that's just going to happen no matter which two angles you choose. Your only two options, you either set them equal or you add them together and they equal 180. So just to finish it off, if the drawing looks like this, it's pretty easy to just kind of tell which angles are the same. And if they don't look the same, then they must add up to 180. All of the angles that are less than 90 would be the same number. We would set those equal. So I guess I'll just kind of highlight them. That one there and that one there, that one there and that one there. Those would all be equal to each other. So if you have numbers in those or variables, then you would just set those equal and solve. Angles that don't look the same would add up to 180. That angle would add up to 180 with that angle. That angle would also add up to 180 with that angle because they don't look the same. If they don't look the same, then the only other option is they add up to 180. So in a figure like that, it's kind of easy to just look at it and say, okay, I know which angles are going to be the same. The challenge is if it looks like this, oh, I didn't really want to do that. I could have. If it looks like this, and it's really difficult to tell which angles are less than 90 and which angles are greater than 90, you can't just do it by visually looking at it. So we learned a bunch of definitions. So that's the way I would prefer you to do it is alternate interior, alternate exterior, corresponding, consecutive interior would add up to 180. The other three I just mentioned, they would all be equal to each other. I came up with a little bit of a shortcut, which I'm not a big fan of doing shortcuts. I want you to understand things. What did I just do there? That's actually where I'm. What in the world? Oh, I guess I already had this done up top. I didn't even know it. I came up with a way that you can number the angles that makes it super easy to just know which angles are equal to each other versus which ones would add up to 180. So instead of numbering it like I did originally, and this is normally the way you'll see it numbered like this, 4, and then 5, 6, and then we drop down to 7 and 8. That's typically the way you'll see it. If, however, you adjust that a little bit and you say, well, I'm going to number like this, I'm going to go around in a circle sort of. It's actually called clockwise. This direction is the way the second hand goes on a clock. So it's called clockwise. So I went around in a circle just like that arrow. Then I come down here and this would be 5. So I would drop from 4 to 5 and I do the same thing. 6, 7, 8. Went clockwise again. Now, if you can remember how to number like that, all of the even numbers, all of the even numbered angles are all congruent. 2 is congruent to 4. 6 is congruent to 8. 2 is congruent to 8. 2 is congruent to 6. 8 is congruent to 4. Like, if you have two even ones, they're congruent. If you have two odd ones, they're congruent. 1 is congruent to 3. 5 is congruent to 7. 3 is congruent to 7. 5 is congruent to 1. Like, pretty easy. Even numbers congruent to each other. The odd numbers are congruent to each other. They're actually congruent to the even ones. Oh wait, no, they're not. I'm sorry. So with that in mind, if you have one odd number and one even number, so we'll say, we'll take an obvious one, angle 1 and angle 2, because one is odd and one's even, those would have to add up to 180. which we know is true already because that's the semicircle thing. So again, if you pick two odd angles, they would have to be the same number. If you pick two even angles, they would have to be the same number. If you pick an odd and an even, they would have to add up to 180. So again, when you have a problem, and I didn't do this in class, but I'll do it here. The original problem might look something like this. But okay, didn't do it. 2x plus 4, I will say plus 40 degrees is there. And then this one down here is, oh boy, I want to make sure this makes sense. But I guess it doesn't really matter. 3x plus 10. Oh, that can't be right. God, that's a horrible plus sign. There we go. 3x plus. Hopefully this comes out okay. I don't know if it's going to. I mean, it can't really come out too far off. So I can't really tell visually if should I set those equal to each other or should I add them together and make them 180. So you could number them just like I told you. So this is 1, 2, 3, 4, 5, 6, 7, 8. Now you look, okay, I have one even, so this is 2, so that's an even one. That's an odd one. Well, we said one even and one odd would add up to 180. So you would add those two things together and set them equal to 180. 2x plus 40 plus 3x plus 20 equals, boy, I'm going to run out of room, but that's fine, 180. So that's a way you can do it. Again, whatever you have to do, though, you have to remember which angles are equal to each other. If you can't tell visually, and you have to understand if they're not equal, that you add them up together and they equal 180. So the last thing we did is we did a few IXLs. We only did the IXLs because that was pretty much the whole lesson on parallel lines and transversals. You just need to practice I think it was RSV was the one for that. This is not one that's going to be on there. I'm going to do it real quick. I said these I wouldn't put on because some of these are they're almost kind of opinions. They're a little tricky. So I chose some that there's really like, there's more of a process you can use. But the lesson was if it's a biconditional, we can take the original statement and we can write the converse, so we can switch the order, and both of them will be true. The original will be true and the converse. So if you remember in class, I said, if an angle has 90 degrees, then it is a right angle. That's true. Well, if I flip that and if I say, okay, well, if an angle is a right angle, then it has 90 degrees. That's also true. That means it's a biconditional when both the original statement and the converse are true. A lot of times you're going to get a definition, like right angle is just the definition is it has 90 degrees. Those will typically be biconditionals. We might get to one of these, hopefully, and I'll show you what I mean. Let's see. I might do a few of these since I'm recording. If Ron is going to take a nap, then he is tired. So that's the original. I need to make the converse. I can't. Actually, I can write on here somehow. Yeah, there we go. So the converse would just be, let me take the end part and make it the beginning. So, and I'm going to write if Ron is tired. So I'm going to keep Ron as the beginning. If Ron is tired, I'm reversing it, then he is going to take a nap. So this is the converse. So this is your first step, right? The converse of the original. I'm just going to write going to nap. Should be going to take a nap. So now I have to say, are both of those true? So let's see. If Ron is going to take a nap, then he is tired. We kind of assume that the original is true. Whatever they give us in these, we're just assuming they're true. That's not always the case in the book or other things. Again, just for these IXLs. Now we really just have to determine if the second one is true. So if Ron is tired, then he is going to nap. Well, that's not necessarily true. He might be at work and he can't nap. He might have something else he's doing and he just can't nap. So that's not true. So that means this is not, and some of these we weren't even sure about. They got kind of weird, but feel pretty, yeah, pretty comfortable with that one, right? So again, I'm not going to write all the converses. I'm just going to say them. An essay is printed with the font Comic Sans. Okay, so this is a good one. We do need to go on this. So here's what I'm going to tell you to do. Anytime it says if and only if, I think that gets confusing. It gets confusing for me even. I don't like that terminology. Here's what I would tell you to do. Rewrite this as two different statements. Why is it not working? Oh, I hit it with my thumb, I guess. Hold on. So rewrite it and get rid of the, what is going on? Why is that not working? Okay. Uh, I guess it let me do this in class, but maybe it didn't let. So again, get rid of this part. Ignore that. Or not ignore it, just get rid of it. And we're going to write this as two different statements. And I think that's easier to understand. So the first statement, I will write these, is I just create an if then, but without the, if and only if part. So I just rewrite the whole thing. If, I'm gonna have to abbreviate some of this. If an essay is printed with, that's how I write with, Comic Sans. So now I just make the last part the then. Then Ashley will not read it. So she apparently does not like Common Sans. Apparently, I like it. I don't know why she doesn't like it. Will not read it. So she just doesn't like it. So that's the original. We just rewrite it with, I didn't hit that button. We just rewrite it by getting rid of the if and only if, and we just put if at the beginning, if an essay is printed with Comic Sans, and then we put then in front of the second part. So now is a really long one I have to do. Now, oh, God dang it. So maybe I need to use this. Now we need to, so, okay. So we assume that is true. We assume the original statement is true. Now we write the converse of that. Just make sure I read the question. Yeah. So the converse of that, we just switch the order, and this would be a second statement. If Ashley will not read an essay, then it is printed with Comic Sans. We flipped it around. Now, this is where it got kind of confusing because sometimes we're like, wait a minute, that doesn't make sense. We disagreed with what they were saying. I would say that's not true. Like maybe there are other reasons why she won't read it. Maybe she won't read it just because she's tired or because she doesn't like the person that wrote it or something like that. So even though we say the original is always true, in this case, when we do the converse, I would say the converse is not true, which means that is not a biconditional. For it to be a biconditional, both of them would have to be true. Ah, they say it is true. I understand that. So again, I guess I'm reading too much into it because I could see other reasons why she wouldn't read it. This is why I said it. It got confusing in class. That's why I'm not putting these on there. So again, if it's an if and only if though, you can rewrite it like that. That like actually, can I go back? I'll show you that. That's what they did. Oh man, shoot. All right, here. This is a short one. We'll do another one here. So, so again, I'm going to get rid of. Let's see if I still have that chosen. I don't. I'm going to get rid of. Oh man, I hate this touch screen sometimes. So I'm going to get rid of if and only if. Oh boy, I hate that. You got to apparently start way off of the. I get rid of that, and now I rewrite it with if. So if it is raining. So if it is raining, then. So I just add then in front of Carrie or Kari, whichever one that is. has an umbrella. So that's the original. Now to like write the converse, I just flip that around. And I'm not going to write this one. If Kari has an umbrella, then it is raining. So again, whether or not that's true or false for the second one, I don't know what they're going to say. I would say no, it's not. She might think it could rain, but she doesn't have, like, it doesn't have to be raining. So the converse, if Carrie has an umbrella, then it is raining, to me would not be true. Um, so we'll see what they say. So again, I would say no. I'll bet they probably say yes, but yeah, they're saying yes. See, I don't agree with what they did on a lot of these. So you'll see they wrote the same statements though, like down here. If it is raining, then Kari has an umbrella. If Kari has an umbrella, then it is raining. They wrote the same two statements. We are just disagreeing on how they interpret that second statement. There, to me, there's a lot of other reasons why she could have an umbrella. Doesn't have to necessarily be raining at that point. So I'm not putting those on there. I hope they wouldn't do something like that on the EOC or even the district test that you will probably have to take on this. So I guess I have to get some. Oh no, I can jump levels. Actually, I don't know if I can jump levels though. Let's just take a guess at that and say, yeah, yes. Uh, so, hmm. So I don't know. I'm just kind of guessing now. It seems like they're all yes, but if and only if he's bidding. So yeah, theirs just are all yes. That I don't agree with these. They're still, so maybe I do have to go to the next level. So let's try that. Yeah, here are the ones. So this is not going to be on there. This is doing what I just told you you needed to do. Um, if you get rid of the if and only if, and you rewrite both statements, so if I hit that, if I got rid of all if, oh, it's driving me crazy. I don't know why it wasn't, never did this once in class. So if I get rid of if and only if, and then I rewrite the first statement with if in front of the 10J, so that would be this one, this statement right here. That is the same exact statement written just with a normal if and then. Now I write the converse of that. So the converse would have 8K subtract 5 equals -9 first, and then 10J subtract 8 equals -1 second. So that's this. Those are your two answers. That's not going to be on the quiz, but I want you to try to practice on writing it the way I'm talking about. Take out the if and only if, and then create the two if then statements that would be the original and then the converse. All right, this is what's going to be on the quiz. So the way you can tell when you're practicing, it's the ones that have 6 check marks. You notice there's 6 boxes with check marks on it. So now here's how you do this one. So if it's a biconditional, then you're going to have an original statement and a converse of that original. So you need to find which two statements in here are converses of each other. The process I would use is I would just go one by one and see if I can find a converse for it. So if it's a converse, this part here, oh, it's not gonna let me do this. God, why? I guess maybe the kids I was working with didn't have touch screens in class. I don't know. So this, I don't even know how I'm gonna do it. Maybe if I go up, nope. So how about this? There we go. This part right there will be at the beginning. This part right here will be at the end if that's the original statement and it has its converse somewhere in here. And it's got to be the same. We can't move anything around. We're just switching the order. So let's see. I do have this part here at the beginning, but I do not have 3n subtract 2 equals 10. Well, if I can see if it lets me do this. Oh, it's going to select it, I think, if I do that. Oh, maybe if I do that. So that part is not right. So that one does not work. It's not the converse of the first one because it has 10n plus 3 equals -2 instead of 3n subtract 2 equals 10. So again, I look for m minus 1 equals -4. That needs to be first. Up, here's one down here. M minus, oh, wait, no, that's not right because they have the 4 and the -1 switch, the -4, -1. So there is no converse to this first statement. Nothing, which means it can't be one of the answers. Because when I find the one that has a converse listed, that'll be the correct answer. I don't know how to, oh, actually in this, I guess I have to do this. So I'm going to erase all of this. Or not. God dang it. It's not, I hate this. I don't know why this was so much easier in class, but all right, that's fine. That's good enough. So the first one didn't work. So I'm just going to do this for every single one. So again, I kind of don't really need to test this one because there's, oh wait, actually, yes, I do. I'm sorry. So if it is, if this is the original and there's a converse, this statement here, why did that not work? All right, let's try that again. There we go. Oh, that's right. I erased. So this statement will be at the front of another one of the statements. And this statement will be at the back. It'll get moved to the back. So 10n plus 3 equals -2. Let's see if I have it. 10n plus 3 is -2. All right, there's that. But this statement is not in the back. So that's not it. And there's not another one that has 10n plus 3 equals -2 at the front. So that one can't be it. So now I'll go to this. So again, if I switch the order, 3n subtract 2 equals 10 should be at the front. Well, none of these have 3n subtract 2 at the front. So that can't be it. We never got this far on any of them in class. So if this is it, then m equals -4 should be at the front. Man, I must have messed something up. We're going to run out of, hold on just a second. All right, so let me go back and look at it now. Dude, I messed something up. 3n, or I'm sorry, m subtract 1 is -4 at the front. That's there. M subtract 1, yeah, that can't be it. 10n plus 3 is -2. That can't be it. 3n subtract, so that can't be it. That can't be it. Oh, I guess it's the very last one. Wow, we did not get through any that went this long. All right, so I guess we're fine. So again, this part would have to be at the beginning. This part would have to be at the end. So if I look at the only one left, sure enough, this part right here is at the beginning. This part right here is at the end. That's what the converse are. Wow, that one kind of threw me for a loop there. So then you would select those two. Those are the two statements that are converses of each other. So therefore, they make up a biconditional statement. So that one was, that wasn't tricky. It's the first time we ever went that far into all the statements to find the answer. Okay, I'm going to do another one. Select the two statements that, when combined, are equivalent to the following. This is not like the one I'm just going to guess because I don't want to do that one. That's fine. There, this is what they're going to be like. Again, 6 So when you're practicing, you're looking for 6 statements that have check mark boxes. So I start with the first one. This here, I need to try to write the converse of this first one and see if it's in here. This should be at the beginning. 3q plus 8 equals negative 8. 3q plus 8 equals negative 8. Well, there it is right there. So now, if this statement is at the end of this one, then that's the converse, and I have my answer, but it's not. This says 10p subtract 8 equals negative 7. This does not say that. So that can't be it. So I need to go to the next one. Again, I'm looking for 3q plus 8 equals negative 8 at the front. That's not it. That's not it. That's not it. And that's not it. So if I don't have that anywhere in any of the other ones, then this cannot be one of the correct statements. So I move to the next one. So 10p equals negative 7 needs to be at the front because I'm writing the converse. Well, here's 10p equals negative 7. So this would have to be at the end. Well, that's not 3q, so that's not it. It's got to be the exact same thing. So now I look for 10p equals negative 7. Nope, nope. Okay, so that can't be it. So now I move to the next one. Well, I know this can't be it because, well, actually, I don't know that. 8q plus 3 equals negative 8. Has to be at the beginning. I don't need to check the ones above because if they were converses, I would have already found them for the ones above. So I just need to keep going to the ones below. 8q plus 3 equals negative 8. 8q, here we go. 8q plus 3 is negative 8. So if this 10p equals negative 7 is at the end, which it's not. That is not at the end. So that can't be it either. So I keep moving. So 8q subtract 8 equals 3 has to be at the beginning. Well, there's 8q subtract 8 equals 3. So this would need to be at the front for these to be converses. 10p subtract 7 equals negative 8. Sure enough, there we go. 10p subtract 7 equals negative 8. So this is the original, and then that would be its converse. That's the answer. All right, so that's how you do those. So that's one of the biconditional types of questions that'll be on there. I'm going to go to the next level. I think we have to go to the next level. Oh, I don't remember. Shoot. I don't remember. I may have to go to someplace else to find the other kind just to make sure I show it to you. It is cloudy if and only if it is raining. I don't agree with that one, but I think they said the answer was yes. I think I saw that one. Oh, nope, they didn't. Here we go. This is the other kind right here that we want. All right. So again, it's a little tricky, but what it's saying is you could make it 2 statements. If j equals negative 5, then 4j plus 10 equals negative 10. And you could reverse that and say, if 4j plus 10 equals negative 10, then j equals negative 5. So if both, so that would be, getting rid of this if and only if part in the middle and just rewriting it as 2 separate statements. If both of those statements are true, then it's a biconditional. So the way we figure out if both of those statements are true is we really just plug this number in. Or you could solve this equation right here and see if the answer is negative 5. Because if the answer is negative 5, then that's going to make both statements true that I just told you to create. Let's see. So I'm going to just plug it in. Negative 5 times 4 is negative 20. Negative 20 plus 10 is negative 10. So yes, that would be a biconditional. If j is negative 5, then yes, this is a true statement. If this is a true statement, then yes, j equals negative 5. So the converse is true and the original is true. So again, if you're struggling, just make sure you practice. So here's another one like that. If you solve or if you plug it in and it doesn't work, so 5, so y is 5. Okay, well, 5 subtract 6 is not 1. It's negative 1. So that means really it means both statements are false. The original statement is false and the converse would be false. So that's a definite no. So practice those like that. Anytime, just to let you know, this is not going to be on the quiz. Anytime it pretty much like looks like it's the definition of the word, that's going to be true. Two angles are complementary if and only if their measure adds up to 90 degrees. Well, yeah, that's the definition of complementary. Those biconditionals are always true if you get one of those. I don't even need to like try to figure that out. That's gonna be true. That's what I did when I gave you the example of a right angle is 90 degrees in class. Definitions are always biconditional. You can always flip them around. All right. That's the recording. I don't, and then they just practiced. You see, we're already at a score of 68, and I didn't even get some right and skipped some. Well, I think when I jump levels, so I think my score goes up. Let's see.